Last week, one of Stephen Hawking's last scientific papers was released online. The paper is titled "Black Hole Entropy and Soft Hair" and was published on the Archive, an online paper repository by scientists who had worked with Hawking. The paper continues Hawking's lifelong goal of unravelling the mysteries of black holes. But what does this all mean? First, I want to take a step back and talk about Hawking's work more generally. One of Stephen Hawking's key focuses was understanding gravitational singularities. Einstein's theory of general relativity, the theory that explains gravity, predicts that at the centre of a black hole and at the moment of the Big Bang, everything was crushed into an infinitely small, infinitely dense point called a singularity. But singularities don't make sense. They defy the known laws of physics. Because of this, when a mathematical theory throws up singularities, it's a good sign that the theory is wrong, or at least incomplete. Most physicists don't really believe that there are infinitely small, infinitely dense points at the centre of black holes. Singularities are also very restrictive. They destroy information. In the case of black holes, this adds to the nonsense. But in the case of the Big Bang, this means that we can never know what came before the Big Bang. So to gain a better understanding of the nature of the universe, we need to vanquish these singularities and find out what is really going on in black holes. And that's what Hawking was working to do. One of Hawking's biggest successes, and the discovery that bears his name, is Hawking radiation. If nothing can escape from a black hole, then the energy contained within the black hole can't radiate away into space. This violates the second law of thermodynamics, that entropy, the disorder in a system, must always increase. In a brilliant combination of general relativity and quantum mechanics, Hawking showed that energy from the black hole can briefly appear outside the black hole's event horizon and leak away into space. Through Hawking radiation, black holes can very slowly evaporate away, meaning they do not violate the second law of thermodynamics. But this threw up another problem. In physics, information, like energy, is always conserved. In this case, information means the number of ways something like the atoms in a star can be arranged. If you take some atoms away from the star, then there are fewer possible arrangements of the atoms in that star, and so the star has less information. But the blob of atoms you've taken away contains some information describing the arrangement of atoms in that blob, and so the total amount of information remains the same. As far as we know, when something falls into a black hole, its information is destroyed. So where does this information go when the black hole evaporates away? This is called the information paradox. Hawking, along with his colleagues Sascha Heiko, Malcolm Perry and Andrew Strominger, made some progress in solving this problem. Their working shows that photons of light near the black hole's event horizon can bear a record of this information, a phenomenon that has been dubbed soft hair. But this is not the end of the mystery. Hawking's colleagues still have a lot of work to do to refine the theory and show that it really can account for the missing information. If they can, then they will have solved one of the greatest problems in modern theoretical physics. This is one of the last papers Hawking was working on before his death in March this year, but it's unlikely to be the last paper with his name on. Hawking was working on at least 2 other papers with colleagues at the time of his death. We haven't heard the last from this great scientist.